Okay, good evening, everyone. Welcome to
Good
another
evening.
class meeting. Please bear in mind the rules. Please make sure that you have your videos off, your cameras off for privacy reasons, and make sure that as best as is possible, you're in a very quiet environment and that you're wearing headphones. So we start off with a question on the screen now. It would be, and let's start with Mr. Walker. Walker,
Your pencil, sir.
I'm not hearing you.
I'm going to get a pencil.
Okay, let me see. Someone just joined us with their camera on. Could we take our camera off?
Yes, sir.
That's look like, yeah, that's much better. So while we wait on Mr. or our friend Welter to get his pencil, look at the problem and see what you can figure out from that.
Sir, I'm ready.
Okay, sir. Tell me what do I have here?
4 plus 2
4 tens plus 2
tens.
tens. Um, no, you can't. Somebody's doing something very bad to us, man. Are we ready?
Headphones.
Use the headphones. Can't find it. Whatever.
All right, let's go. So 4 tenths plus 2 tenths. What am I adding, Walter?
Sir, the numerator, because the
They are what?
denominators like.
Okay, so if we have like denominators, we're going to keep our denominator and simply add our numerators. Okay, so 4 and 2 would give us what?
6, sir.
6. Is there anything else I can do with this 6 over 10?
Yes, no, sir.
Of course,
Sir,
yes, I can. I can what?
reduce.
I can reduce by using the same factor for the numerator and the denominator. Any factor I use for the numerator, I also need to use for the denominator. 10
Yes.
is even and 6 is even. Therefore, I know I could use what?
2, sir.
2. Okay, so 2 into 6 would go how many times?
3 times.
3 times. And 2 into 10 would go?
5 times.
Okay, so now I have what? 2. Answer, what do I have as the answer now?
2 sir, fifths. Supposed to be
I have
3 fifths, sir.
3/5 because 2 into 6 goes 3 times. All right, good. So 3/5. So 6 tenths is the same as 3/5.
Yes.
All right. So what we need to remember is that in this case, we do not need the LCM. Do we need the LCM here? No. Why?
No, sir.
Because the LCM would have been what? 10.
10.
And if it's 10 already, we would get the same thing back, the same 4 tenths, the same 2 tenths. So we just keep the denominator and move on with that. All right.
Yes, sir.
Here I have, let me give this one to Trishan. Trishan, 150 divided by 3 is equal to 50. This 50, what is it called?
Sir, that is the core. Oh,
Is it the remainder? Is it the quotient? Is it the divisor or the dividend?
The remainder. No, sorry, quotient.
Okay, it's the quotient. And the quotient is the answer we get. The remainder would be anything that is left over. The divisor is the number we are dividing by. and the quotient is the dividend is the number that is being divided.
Yes, sir.
Got that?
Yes, sir.
Yes, sir.
Yes, sir.
Remember also that there are different ways of setting out the division problem. So this is set out how? Horizontally. We could set it out what? Vertically, like a what? Fraction. And
Yes,
we could then say 3 into itself one time and 3 into 15, 5, 3 into 0, 0. So we end up with what? 50 over 1, which is the same as what? 50.
50.
We could use our fraction what? Frame. 3 would be our divisor that goes outside. 150 would be our what?
Dividend.
Dividend that goes inside. Now 3 into 1 can't work. 3 into 15.
15.
What do we need to remember? That what? Every
Dog must swim back.
dog must swim
Back.
back. Let's add our signs as possible. Divide, multiply, subtract, and bring down. Okay, so we estimate. All right.
Yes,
So
sir.
here, 3 into 15 would go about how many times?
5 times.
Okay, so we're going to multiply. 5 threes would give us what? 15. Then we're going to what? Subtract. We have 0. We're going to bring down 0. And 3 into 0 would give us 0. All right. And of course, you could say 0 times 3 would give us 0. And 0 from 0 would still leave us with 0. So any way that we set it out, we are supposed, whether it is horizontally, whether it is vertically, or whether we're using the fraction frame here, we are supposed to get 50 as our answer. Is that clear?
Yes, sir.
Remember, with long division, we need to estimate, divide, multiply, subtract, and bring down. Okay, let's go to this one. We have 8.739 rounded to the nearest hundredths. I'm hearing somebody in the background there. Let's remind the people in our background that they have to be quiet because this is being recorded. Okay. So let's go. I'm gonna ask Talia to do this one. Are we ready? Are we ready now? Talia, this one is yours. 8.739 rounded to the nearest hundredths. What do we need to do? All right, I'm not certain that she's ready, so let's ask Akeem. Are you there?
Yes, sir.
All right, tell me what I need to do with this one to round it to the nearest hundredths. Do you remember?
No, sir.
All right, well, let's go back to Welter. Welter,
Yes, sir.
what do I need to do to round this number, 8.739, to the nearest hundredths?
So you look at the digit to the right, and if it is 5 or over, you round up. If it is 4 or less, you round down.
All right, so let's help me to identify the different place value. The 8 would be in the what column? So this is our ones column. The 7, it being, you know, right of the decimal point,
Yes, sir.
would be in our what?
Tenths place.
Tenths. What about the 3?
Sir, hundredths place.
Hundredths place. And the 9?
Thousands place.
Thousands place. Okay. Not certain why that one not writing up there. Well, let me try this again. Okay. So we have 8 whole, 7 tenths, 3 hundredths and 9 thousandths. So I need to round to the nearest what? Hundredths. So this is the number that I am rounding.
Yes, sir.
According to the rule, what do we need to do? Look at the digit to its what?
9, sir.
Today, right. The digit to the right is 9. Now, if it's 5 or more, we round up. If it is 4 or less, we round down. The 9 is more or less,
Sir, more, sir.
which means that we're going to add 1 to the digit that we are rounding and put 0 for the rest, the numbers behind. Okay, so what do I have as my answer? Tell me what I need to fill in.
Sir, 8.74.
74.
No, sir.
So 8.74. We could put 0 here for the 9 that was there. However, we know that this 8.74 is still equivalent to 8.740. Got that one?
Yes, sir.
Okay. Any questions on that? Anybody else?
No, sir. No, sir.
Sally, are you ready now?
Yes, sir.
Okay, it says arrange in descending order. Now, descending order, what does that mean again? I'm going to draw 2 little things here, and you tell me which one is descending again. Is this which one this is?
Sir, which one?
The one on the left.
Sir, that is descending order.
No, which one? This one is descending.
No, sir.
This one is ascending. This one is ascending, and this side is descending. So ascending means that I'm going to go from smallest to greatest,
Yes.
while descending means that I'm going from greatest to smallest. Okay. So arranging descending order, which means to go this way from greatest to smallest. What's the next step that I would need to take, Tally, in order to complete this one? Any ideas? We're comparing fractions here. Any ideas on this?
Sir, I try to remember. Oh, yes, sir.
What would we need to do?
In descending order, sir, you're going to so you're going to find the LCM of the denominators.
Find the LCM of the denominators. Okay, so let's use prime factorization 6, 4, and 3. And let's start off with our smallest prime. That's usually how we do it. So 2 into 6 would go
1. 2 times.
for real. 2 into 6. 2 into 6.
3 times.
Okay, and 2 into 4.
Sir, 2 into 4 goes 2 times.
And 2 into the 3, what would we do?
But the 2 cannot
Right
go
back
into
the 3. Okay. Do we need to use 2 again?
no, sir.
Yes, we need to use 2 again. 2 into the 3, it won't go exactly, so we'll write back 3. And 2 into 2 one time, and 2 into 3 again, we write it back. What do I do now?
Sir, 3.
Okay, so 3 into 3, 1. Write back our 1, 3 into 3. Okay. So as I like to say, let's draw our L and multiply everything outside. So this would be 1 times 1 times 1 is 1. 1 times 3 is 3. 3 times 2 is 6. And 6 times 2 is
12.
So the LCM here would be 12.
12.
If this is 12, no, help me now, Tally. What do I need to do next?
So you're going to say 6 into 12.
Can hardly hear you. Somebody has a dog barking in the background there. Whoa. Tell me,
So you're going to say 12 into 6 goes 2 times and write the 2.
what do I do with that factor of 2, that factor?
So you put it up at the top.
I use it to multiply the numerator. So 2 fives would give us what?
10.
Okay. 4 into 12 would go how many times?
3 times.
Okay, use that factor now, the factor 3, to do what?
So to multiply the 1, you're going to say 3
And
times
the
1 equals 3.
and the one is the what? The
So the 1 is
numerator.
the numerator.
Okay, so 3 ones would give us.
3.
Okay. And 3 into 12 now would go how many times?
4 times.
And 4 times 2 would give us
8.
8. So what we have done, we have made all of these fractions equivalent by sharing the same what? Denominator. So 5 6 is now 10 12s. 1/4 is now 3 12s. And 2/3 is now 8 12s.
Yes,
Now that we have them with the same denominator, we can put them in descending order. So Tally, what do we start off with? Which one is the largest one here?
So 5.
5 6, because it represents the 10. Okay.
10.
Then
So and 2/3.
and then 2/3, as it represents
So and then a
the 8
quarter.
tenths, and then a quarter. So that is arranging them in what
Descending
order?
order.
Descending
Descending
order. Okay. All right, let's go back to Trishan. Trishan, there? Okay, speak up a little bit more for me, please. Okay, here we want to know what the ratio of bananas to apples would be. How many bananas do we have?
2.
And how many apples?
4.
4. So the ratio of bananas to apples would be what?
2/4.
I prefer if you do it like this and say 2 to 4. So the ratio is 2 to 4. Every time we have 2 to what?
4.
4.
No. Which one of these? The 2 represents the what?
Banana.
So every time we have 2 bananas, we should have how many apples?
4.
4. Okay. Now we can change this 2 to 4 into the fraction, as you mentioned before. What? 2/4, 2/4. And then we could do what? We could reduce. Who is that joining us? That person needs to turn their camera off.
Brian.
I'm coming, sir.
Let's maintain our privacy. So we could reduce, right? So Trishan, what factor can go into both? What number can go into both the 2 and okay? So 2 could go into 2 how many times?
1.
And 2 could go into 4.
3 times.
Okay. So I end up with 1/2. Yes.
Yeah.
How do I change this back now to a ratio? What do I need to say? The ratio would be what?
1 to 2.
1 to 2. Excellent. 1 to 2. So ratio is a way of what? Comparing what? Quantities. And in this particular situation, I'm comparing bananas to apples. Every time that I have what? 2 bananas, I will have how many apples? 4. Okay. Let's look at this. If I reduce this, and notice what I have here.
Mhm.
Every time I have one banana, I will have two
Two
apples.
apples.
Look at this and look at this. See that?
Yes, sir.
All right. All right, let's go. Mr. Sharp. Mr. Sharp,
Yes, sir.
a box containing 72 pencils. A box contains, rather, 72 pencils. It was shared equally among 6 students. So 72, and it was shared among 6, which shows what each student will get. So which one of these will show what each student will get?
Sir, 72 divided by 6.
Okay. Are we all agreed on that one?
Yes, sir.
Yes, sir.
Okay. What is the key word that I'm looking for in this problem to tell me what to do?
Shared.
Shared.
Yes, sir. Yes.
This word is associated with which operation? Division. Not subtraction, not addition, and not, but this is also division, you know. But am I dividing 6 by 72 to find out what each student would get? No. 72 divided by 6. Remember that division is repeated what?
Addition.
No,
Addition.
it's not. No, it's not.
No, sir. Multiplication.
Division is repeated subtraction. Okay?
Mm,
Yes,
yes,
sir.
sir.
Multiplication is repeated addition, but division is repeated subtraction.
Yes, sir.
Got that one?
Yes, sir.
So look at it. If I have 6, 1, 2, 3, 4, 5, 6, and I take out 2 out of it first, then I will have how many left? 4. And then I take out 2 again, then I will have 2 left. And if I take out 2, then I have none left. How many times did I take 2 out of that? 3 sets of 2. What we just did there was repeated subtraction or what? Division.
Division.
Got it?
Yes.
Yes.
Let's go back to Mr. Walker. 3.5 cakes were shared equally among 7 students. So 3.5 shared among 7 students. What portion of the cake did each student receive? What type of problem is this? So Walker?
Fractional problem.
Yes, but what type of fractional problem?
Sir. Oh, division, sir. Division.
All right, so tell me what I need to write out here now to solve this.
Sir, 3.5.
Hold on, 3.5. Yes.
Seven. Seven.
Which operation you say again?
Sir.
Okay, divided by 7. So what do I need to do now?
No, sir. You're going to put the mixed number into a improper fraction.
How do I do that?
So you're going to multiply the numerator by the whole number and add the numerator with their answer.
Okay. I prefer to use the denominator multiplied by the whole number and we add the numerator. So 3 twos would give us 6. 6 and 1 will give us what? 7. Pick up this 7. So we have 7 over 2 divided by 7 over what?
1.
1. Why do we put 1? Because we want to change the whole number into a fraction. What's the next step, sir?
So we're going to keep the first fraction,
We're going to keep, then we're going to what?
change the
Change, and we're going to flip. Why do we need to keep, change, and flip?
so because division is I don't remember.
Anybody wants to help him? Anybody remembers the little saying? A fractional division problem is simply a what? Multiplication problem in disguise. So let's keep this 7 over 2. And in the division problem, what is the 7 over 2? Is it the quotient? Is it the divisor? Is it the dividend? Is it the remainder? What is it?
The dividend.
Okay, so we're going to keep the dividend.
Yes, sir.
7 over 2. We're going to change the sign to multiplication. And we're going to flip this number. What number is this one?
1 over.
No, what will it be? What is it? In the division problem, what is it?
Divide.
It's the divisor. And we flip the divisor or invert or find its reciprocal.
Yes, sir.
So where do we go from here?
Multiply.
Can we reduce?
No, sir.
Of course. 7
Into
into itself one time and 7 into 7 one time. We end up with 1 numerator by numerator 1 over
2.
2. It would be the same thing though, you know, if we had said 7 over 2 multiplied by 1 over 7, and we said 7 times 1 is what? 7, and 2 times 7 is what? 14. And the what? The highest common factor of 7 and 14 would be what? 7. So 7 into 7 would go how many times?
1.
1 time. And 7 into 14 will go 2 times. Numerator 1, denominator. So we still end up with the same thing.
Yes, sir.
Okay? So it's a half. Each of them each student would get a half. Any questions on that one?
No, sir.
Clear?
Yes, sir.
Okay, if it is that we have a division problem like this, 6 being divided by 2, we say 2 into 6 would, how many times? 3. 3 twos would give us 6, subtract, get 0. How do we test this answer? What do we do?
The code.
Multiply the quotient by the what?
Divisor.
By the divisor. So can we test this one? So multiply the quotient by the divisor and see if we'll get back the whatever. What's the quotient? What's the answer? A half. What can we test it by now? What's the divisor? What's the divisor?
7 over
7 over 1. Okay. So now numerator by numerator would give us 7, and denominator by denominator would give us 2.
Yes, sir.
Can I reduce this? The 7 over 2?
Yes, yes, sir.
I can change it to a what though?
number
Can change it to an improper fraction. How do I do that?
by multiple.
Sing how many
times can go into 7.
how many times?
So
3 whole times. Remainder what?
1
1
over 2.
over 2.
Yes, sir.
So there we have it. We have solved it, and we have even gotten to the point where we could check to make sure that it is right.
Yes,
All
sir.
right. Let's go back down the line. Tally, are we ready? Ready, Tally?
Yes, sir.
A child is sent to the shop and purchases items totaling. How much money is this?
What did you say, sir?
How much money?
Sir, $2,809.27.
Okay, so 2,000. Sorry, not 2,000. $289.27. What is the change that this person would get from $500? First, you need to tell me what type of operation is needed to solve this problem.
Sir, that is a subtraction problem.
Okay, so which number needs to go to the top?
Sir, $500.
Okay, so 500 needs to go here. I'm going to include my cents. Which number needs to go to the bottom?
Sir, $289.27.
$89.27. Okay. Okay. Let's go through this now, Talia. Can I take this 7 from 0?
Sir, you have to borrow from 5.
I'll take from the 5, take 1, leaving with 4. That 1 will go beside this 0, causing it to be 10. Take away 1 from it, 9. That 1 comes beside here, and we repeat this, so this will be 9. This is also going to be 10. Take out 1 from that, leaving this with 9. And finally, the 1 gets all the way over to where we need it. This becomes a set of 10. 7 from 10 would leave me with what?
3.
Why? 3 and 7 makes?
10.
Okay, remember that addition is the inverse operation of subtraction. So if I want to test if my subtraction is correct, then I can just do the addition to prove. So here we had 10, and we take out 7. We should be left with 3 because 3 and 7 would make 10. Let's go 9, and we're going to take out 2. What should we have left?
7.
Let's all wait our turn. So what do I need to consider next, Tally?
Decimal point.
So decimal point under decimal point. We have been working what? Column by column. We put the decimal point on the decimal point. So we go over to the next column now. Okay, next column.
Sir, sir, 8 from 9 will leave with 1.
Because 1 and 8 makes? 1 and 8 makes?
9.
Okay. Next column now.
Sir,
Can hardly hear. Someone is really moving that microphone around or rubbing it on some clothes or something like that. It's not fair to the rest of us. Our answer here would be 2. So you tell me what this answer is in terms of dollars and cents, please.
sir, the answer is $210.73.
So if I send that child to the shop and they buy things that total $289.27, what change should they get back from $500?
$210.73.
how can I check my work now to make sure that it is correct? What do I need to do?
Um, sir, I don't remember.
Okay. What Mr. Walker, what can I do?
So the answer is take 110 and the 289 points.
Oh, okay. So what do we call that again? We have the special name for the 500 would have been the what?
The
No, man.
subtract
No. That would have been the m- minuend. The number we're taking out would be the subtrahend, and our answer would be the what? Our answer would be the difference. Our answer would be the difference. Remember that each of the numbers in the problem has a special name. So we have the
third minuend,
minuend, subtrahend, and we have the
and
difference. So in order to find out, in order to check our work, we need to add the difference and the subtrahend to see if we get back the
One.
minuend. So
Yes,
let's go
sir.
with this. 289.27 plus 210.73. Let's add to see if we're going to get this.
Dollars.
So say that again for me.
Sir, about $500.
Okay, let's do it. Let's do work it all together. 3 and 7 would give us what?
10,
10. So we're gonna write 0 and carry.
1,
So 1 and 2 would make
499.
3. 3 and 7 would make 10. Again, we're going to write 0 and carry 1. What do I need to? Okay, very good. Decimal point under decimal point. 9 and 1.
10,
Okay, 10. So we're going to write 0 and carry 1. 1 and 8.
9,
9 and 1.
10,
10 again. So now I'm going to write 0 and carry 1.
yes,
2.
sir.
1 and 2 would be what? 3 and 3 and 2 would be what?
5,
Okay, so we end up with what? 500 flat.
$5.
Okay,
Yes, sir.
so please remember, yes, when you're going to the exam, take
Yes,
the
sir.
time to check your work by using the reverse operation where necessary to prove that your answer is actually correct. Okay,
Yes, sir.
we have only 2 of them left. Let me see. Let's go. Who is Cool Kids again? Is this Sandra? Sandra? Not hearing him. Is he there?
He's on hold.
Sandra? All right, so let's.
Yes, sir.
Okay, you're here. Good. If there are 50 marbles in a bag, Jack gets 5. Jack gets 5. Paul gets 9. The rest of the marbles are shared equally between 2 boys. How many marbles will each of these boys get? How do
Sir,
I?
9. No, sir, not 9. 27, sir.
All right, let's see. What's the first thing I need to do? I know that I have 50 marbles, and we're gonna take out some. Who are we taking out some for?
Jack.
Jack. How many did Jack get?
5,
And how many did Paul get?
9.
9. Okay. Then whatever is left, I'm going to do what?
Divide
Share it by how many?
2.
Okay. So it should look something like this. Let's go. Whatever is in the bracket, we need to work out. So I'm going to say 5 and 9 will give us what?
14, sir.
14. If I add 50 and I take 14 from it, what will I have? We're going,
36, sir.
okay, but we're going too slow though. All right, so if I have 36 and then I divide that by 2, what should I have? Anybody?
Sir, working it
30,
out.
36 divided by,
Sir, 80.
okay, all right. So each of these boys will get how many marbles, Sanjay?
18, sir.
18. Let's test that to see if that is so. Now, what do I know at this point? Each boy will get 18. So, boy 1 will get 18 plus what boy 2 get, which is 18 plus who else?
Boy, yes,
Jack
sir.
gets how many? 5 plus
Paul.
who? Paul. And Paul gets how many?
9, sir.
9. Okay. So 18, we need to work out what is 18 and 18 plus 5 and 9. So 18 and 18 will give us what?
18 and 8. Sir, sir, can I
Taking, sure, go ahead.
Sir, 36, sir.
36 plus 9 and 5 or 5 and 9.
14, sir.
Okay. So what is now 36 plus the 14?
Sir,
6 and 4, 10. Right? 0, carry 1. 1 and 3, 4. 4 and 1.
4.
So we have gotten back the 50 that they mentioned here. So that means that my answer is what? Correct. So I am certain that each boy would have gotten 18 marbles. So it's when I work it out like this and I test it, when I'm done with the exam, I can have confidence that, you know, I have done well and that the questions have been answered correctly.
Yes, sir.
Let's go to the last one for this evening. And this one, I doubt that you have seen any like this since we have started. But let's see if we can use our head and figure this out.
Yes.
3 hours and 30 minutes minus 1 hour and 40 minutes. The ratio of hours to minutes is 1 hour to 60 minutes. How do I subtract this? Because if you notice down here, I have 40 and I need to take this from 30. What would I need to do?
Sir, you're going to take one from the 3 and it's going to give you 60 over there, sir. And you're going to add the 60 with the 30, sir. You're going to get 90, sir.
Okay, so
And then you add the 9. No, subtract the
the
40.
40. Okay, so 40 from the 90 now would leave me with what?
Sir.
50. I'm going to use my signs as needed. And 1 from 2 will leave me with
1.
1. Simple that, not true?
Yes, sir.
Yes.
Easy. All we need to remember is that what? 1 hour is equal to 60 minutes, or that 60 minutes is equal to 1 hour. So
1
if
hour.
I'm going to take from the hour side and bring it over, it must be that I'm going to add the 60
Yes, sir.
to whatever was there before. So
Yes,
60
sir.
plus the 30 here. This is what gives me the 90 that was mentioned here. And now I simply take the what? 40 from the 90, leaving with 50. And I had...
Sir Jaden's mommy was showing us that in grade 5, sir.
Okay, very good. Well, that brings us to the end of the session for this night. I hope that we were paying attention and that we have, gotten some practice in. I encourage you to use all your free time to work on the mathematics. Please make sure that we know the tables, the multiplication time tables, so that when it comes on to the calculations, we can just rattle off the multiplication facts easily. Is that clear?
Yes, sir.
Yes,
So we must all study that. Okay, guys, thanks for joining. I will see you in the next episode and have a good night.
Yes,
yes,
sir.
sir.